Even if we were sure Earth would be fine forever, do you want to be here forever? Do we have a spurt of adventure? Do we want to go out there and see the rest of the universe? Do we want to find out what's out there and maybe meet some alien civilizations? And if so, we need to be a multi-planet species. That's the next step, and then we can go from there to being a multi-stellar species.
Tonight on J-Lo's Garage.
We're getting ready to put the engines on.
A little different than doing an engine swap at the garage.
I meet up with one of the greatest innovators of all time,
Wow.
Elon Musk. And he's giving us an exclusive behind-the-scenes tour of a spectacular SpaceX Starbase facility.
You built this whole thing in 2 years.
Yeah.
He'll show us how he's turning his sci-fi dreams of human life on Mars into an incredible and attainable reality.
We're making one of these every 3 days.
Really?
Yeah.
And that's not all, because Elon's innovations have also made the auto industry even more exciting. Now, things might get a little dangerous.
There's so much new technology in here, there's a good
Right.
chance the whole thing blows up.
Who has graciously invited us all down for a visit to his state-of-the-art SpaceX launch facility outside Brownsville, Texas.
I'm here at Starbase talking with Elon. Good to see you again, my
Hey,
friend.
good to see you.
Now, it's not often you meet up with the richest man in the world, but Elon Musk and I have some history. He came by the garage with his very first electric roadster way back when.
6,831 batteries, is that what it is?
Yeah.
And let's just say his latest appearance on this show was super boring.
Let's see, how are we?
I think you're looking good on this side.
Okay, here we go.
You see what I did there? Now, when he's not upending the auto industry with high-performance electric cars and trucks, busy building tunnels below cities or hosting SNL, he's over at SpaceX pushing the limits of outer space and technology. In fact, thanks to their tireless pursuit of reusable rockets, life on Mars may come much sooner than we think, especially if Elon has anything to say about it.
This is very inspiring, because I was one of those people, I was all into the space race, and then we just walked away from it. And now it's back, and all these kids are here doing this because of you, and you're their inspirations. That's got to feel good.
Yeah, I mean, I think we've got an incredible team, and we're making great progress here. We're trying to achieve the holy grail of rocketry, which is a fully and rapidly reusable rocket. No one has ever made a fully reusable orbital rocket, and never one that could be rapidly reflown like an aircraft. And that is actually the essential sort of invention, if you will, that is necessary to make humanity a multi-planet species.
And it seems like common sense. I mean, you wouldn't get in a plane, fly it once,
Yeah.
and then wreck it,
Yes.
and then build
That'd be
another
insane.
plane.
Yeah.
So
like,
I
it'd be
mean,
like the current, the way that rockets used to be would be like if you bought a plane and then you over your destination you jump out with a parachute and then the plane crashes.
Right.
And that's actually how rockets work.
Why do you think it was not done before?
I mean, it's a very hard engineering problem. You need a lot of advancements on the engines, the airframe, the heat shield, and all of the technologies that go into the rocket in order to have it be reusable but still get payload to orbit.
Right.
Getting to space is easy,
Right.
but getting to orbit is 100 times harder than getting to space.
Really?
Yes.
Okay.
Confused? Let me try to explain. First things first. It's hard to believe space is just a mere 62 miles above the Earth. Yeah, fewer miles than, say, a round-trip drive to the nearest outlet mall. But what we call low orbit sits at around 100 to 1,200 miles up and is way harder to achieve. Primarily because it takes a lot more propellant to not only get there, but to maintain enough speed to stay up in orbit. And if an object can't maintain a fast enough orbital velocity, it'll eventually fall back into our atmosphere and probably burn up on re-entry. And since the current price for launching a SpaceX Falcon Heavy rocket is $97 million, we definitely don't want that.
These have been reused, these ones here, correct?
Some of them, yes.
Yeah. I like the patina of it because it just has a look of a vehicle in use, you know?
Yeah.
They look like they've been into space.
Yeah.
The whole thing is built on site here, isn't it?
Yes. We built them in this high bays here and in the sort of factory behind the high bays. But the public isn't really aware of this, and I think this would be just a good thing to educate people on. It's just how absolutely fundamental it is to make a fully reusable rocket.
Right.
It's profound. Going back to the aircraft analogy we were talking about, if you had to throw an airplane away after every flight, it would be so expensive that nobody could fly.
But see, that's what I love is the passion that you have, because most people in your financial position, they would have yachts and racing cars and places on the Caribbean and whatnot, but you put it all into this, don't you?
Yeah, I live here. I actually rent a house from SpaceX in the little village over there.
Yeah.
I spent about half my time over the past 2 years just getting this place built.
Yeah, I mean, I think it's just incredible.
Now, the SpaceX Starbase sits on just over 100 acres of land right on the western edge of the Gulf of Mexico. And a lot has happened here at Starbase since they first broke ground way back in 2014. The first tracking antenna was installed in 2016, and the first propellant tank arrived in 2018. In 2019, they successfully tested and flew the first prototype test vehicle, dubbed Starhopper. And as of March 2020, Starbase had over 500 people on site working here 24/7 on the incredible third-generation SpaceX vehicle, Starship, which had its first successful test flight in 2021.
Now, this is the most impressive thing I've ever seen.
So this is our Starship. This is what goes all the way to orbit. This sits on top of the booster.
Right.
The ship is about 165 feet tall.
Yeah, I don't think anybody has any idea how big this is.
Yeah, it's 30 foot in diameter on the inside.
Yeah, because when you see it on TV, you're watching it from a half a mile away.
Yeah.
I mean, you're sending the Empire State Building into outer space, basically. Here.
Yeah, it's a gigantic building. In fact, the payload area has more volume than a 747.
Wow.
So, but we can get closer if you want.
Yes, can we get a little closer?
You don't have to get too close to realize that the SpaceX Starship is an absolute technological marvel. The complete rocket consists of the booster stage below with the sleek-looking and state-of-the-art Starship spacecraft on top, which is constructed with a specially formulated stainless steel body. And simply put, it's the tallest and most powerful rocket ever built. Plus, it's reusable, which means huge savings on launch costs and more money for, say, lunches. Ooh, that looks good. But amazing design aside, the real magic at SpaceX is in the manufacturing.
You're the only person I've heard talk eloquently about the actual manufacturing, because that's the hard part. Anybody can draw a rocket.
Yeah, manufacturing is by far harder than the design. I mean, there's an old saying, it's like 1% inspiration, 99% perspiration.
Right.
I think it might actually be 99.9%
Yeah,
perspiration. Actually, in America, I'd say we underweight the value of manufacturing.
Right.
Manufacturing is extremely important, fundamental, and a very difficult thing to do. Even making prototypes of the rocket is easy compared to manufacturing a whole bunch of them.
Right.
So we're gearing up to make one of these per month, and then within a few years, be making one of these every 3 days.
Really?
Yeah.
You know, I always say we won World War II, not necessarily because we had the best soldiers, which we did, but we were able to make a bomber every hour at a Willow Run. I mean, we actually built planes faster than the Germans could shoot them down. And there's still an awful lot of handwork on these, isn't it? It's men with welding equipment and tools and putting a rocket together, isn't there?
I mean, there is quite a bit of automation.
Right.
So we use lasers, like laser weld for all the larger welds. It's a machine doing a very precise laser weld.
And what you want to do here is build what? A total of 1,000 rockets?
How many rockets are needed to create a self-sustaining civilization on Mars? It's probably on the order of 1,000. So you can only go to Mars every 2 years.
Hold on a second. 2 years? Well, that's right, because every 2 years, Earth and Mars are orbitally aligned to allow for the shortest route between them. Okay, Elon, take it away.
So if you've got 1,000 ships, if you're able to put 100 people on that ship, that'll be 100,000 people every 2 years. And so it'd take you 20 years to get to 1 million people. I figure, I don't know, about 1 million people is probably what you need to create a self-sustaining city on Mars.
Well, that's why I love you. Always think big. I remember talking to you years ago about trains, and I was saying, you know, 200-mile-an-hour train. You said, no, mine will be 800 miles an hour. I mean, you're always thinking that next step ahead, which I love.
As long as one is not breaking the laws of physics, it can be done.
And the SpaceX team is using those laws of physics combined with all new manufacturing innovations to build the most efficient and powerful reusable rockets ever made.
The Starship is 2.5 times the thrust of a Saturn V.
Wow.
Saturn V was the largest rocket ever to reach orbit, and this is 2.5 times more power than that. And one a month, and they're meant to be reusable. We're talking about something that ultimately, as a system, is thousands of times more capable than the Saturn V program.
Boy, that's amazing.
When stacked and fully fueled, the Starship and booster module together weigh around 11 million pounds. And at 30 feet wide and 390 feet high, it's also taller than the Saturn V rocket by around 30 feet. And of course, like any rocket bound for the depths of space, it's going to need fuel. A lot of fuel.
Because there's no air in space, you actually have to carry your oxygen with you. The rocket is almost 80% oxygen. And then the fuel is the simplest hydrocarbon, which is methane, CH4. So it's liquid oxygen and liquid methane.
And what is the ratio?
It's almost 80% oxygen by mass and just over 20% liquid methane. And we also subcool the oxygen, liquid methane, so they're actually even colder than their initial liquid point, and this increases the density. So as you cool them, they even as liquids, they shrink.
Right.
You can get more propellant on the vehicle. This is intended to be the first ship to attempt to reach orbit. There's so much new technology in here, there's a good chance the whole thing just blows up. But we have another ship behind that, another booster behind that. If the first one doesn't work, we'll fix the issue and we'll launch again. So by the time this is stacked on the launch pad, we'll have a second ship waiting.
And how many of these would you test before you do human cargo?
I think we'd have hundreds of flights before we did
Oh,
people.
okay,
Yeah,
hundreds, okay.
Yeah, probably hundreds.
But when you're building one every 3 days, that's going to happen pretty quick.
And each one that we build can be launched daily, if not multiple times a day.
I remember we talked once, you had an F1 McLaren, and when that came out, it was 2,000 hours to make the carbon fiber tub. And then now the P1, it's 90 minutes.
Wow.
So it's that same type of manufacturing efficiency you're looking for.
Yes, manufacturing efficiency is essential.
And the fact that all this was done in just a 2-year period.
Yeah, we're getting ready to put the engines on.
Yeah. A little different than doing an engine swap at the garage.
Well, we can take a look at the booster as well.
Yeah, let's see that.
Coming up, we explore more of the SpaceX Starbase, where Elon will show us how he's giving the future of space travel one great big boost.
The astronauts, are they steering it, or is it all done on the ground from here?
It's automatic.
No parallel parking, in other words.
Today we've been touring the spectacular SpaceX Starbase facility located down in Texas with one of today's true visionaries, the incomparable Elon Musk.
But you've built this whole thing in 2 years.
Yeah.
When we left off, Elon explained how manufacturing a usable rocket is a major hurdle. So while making one rocket sound like a walk in the park, in order to realize Elon's dream of making humanity a multi-planet species, the reusable rocket manufacturing process must be absolutely cost-effective.
Something I've heard you talk about, which I've never heard anybody else talk about, is cost per ton.
The point here with the cost per ton is not like some mercantile sort of, businessy thing, but really from a practical standpoint, what level of resources is necessary to get enough mass and enough people to Mars to have a self-sustaining city. And the self-sustaining part is important. If the ships from Earth stop coming for any reason, the city can't die out.
Right, right.
That's a very important threshold. Right now, the cost per ton of payload to Mars is over $1 billion. In order for a self-sustaining city to be created, we need to improve that by probably 10,000 times.
So 100,000 per ton.
Yes.
Okay. Well, that would be an improvement. How do you get that cost down?
Reusability is essential. That's the key to it.
Yeah, okay. How much rebuildability is necessary after one use?
No, I'm going to say rapid. It's going to be rapid and complete reuse. Okay. It lands, you refill the propellant, and you take off.
Really? Just like refueling a car?
Yes.
Wow.
But just a tad more expensive. Oh, and your mileage may vary. Now, if you thought the Starship module was stunning, wait until you behold the Super Heavy booster. Standing at 230 feet tall, the booster is the bottom module of a complete rocket and does all the heavy lifting to get the Starship into space. Like the Starship, the SpaceX Super Heavy booster is made of a specially made high-grade stainless steel. Each booster is equipped with 33 incredibly powerful Raptor rocket engines capable of delivering 500,000 pounds of thrust each. And to deliver the payload necessary to make the mission a success, they need every bit of it.
So the first engine we developed is called the Merlin engine.
Right.
That uses basically a refined form of jet fuel and oxygen. It's a much simpler engine than the Raptor.
Methane is a more powerful fuel than...
Methane is a more efficient fuel than kerosene, which is jet fuel. Most people don't realize jet fuel is just kerosene.
Right, yeah. All the engines identical power or different? Yeah. And they move, don't they?
So there's 20 engines on the outside, and they don't move. The 13 engines on the inside do move to steer the rocket.
Okay. Now, the astronauts, are they steering it, or is it all done on the ground from here?
No, it's automatic. It's on autopilot.
Okay, all autopilot.
Yeah, you can't steer it. It's
No.
too...
Yeah.
Requires too many adjustments per second.
No parallel parking, in other words.
Yep.
And speaking of parallel parking, another crucial technological innovation SpaceX has developed is a gargantuan two-armed tower, affectionately known as Mechazilla.
In order to achieve a full and rapid reusability with the rocket, we need to be able to place the rocket onto the launch stand quickly,
Right.
or place the booster on, then place the ship on top of the booster, and then when they come back, we need to catch the booster with the giant Megazilla arms and put it back on the launch stand, and then catch the ship and put it back on the booster. So we built this giant Megazilla tower to be able to lift and catch these gigantic rocket parts. It's never been done before, so I think it'll work, but it might take a few tries.
And Elon's optimism is not unfounded, because for every SpaceX misstep, and there's been a few, they've had a far greater number of successes. Like creating the first privately funded liquid propellant rocket to reach orbit, the first private company to launch orbit and recover a spacecraft, the first vertical takeoff and propulsive landing of an orbital rocket, and the first private company to send astronauts into orbit, among many, many others. But all of these milestones are essential steps in order for Elon to achieve his ultimate goal of colonizing Mars. But it's important to remember that when paving the way for others, there's always inherent risk.
I'd say life on Mars is difficult, dangerous. People might die. It's just fundamentally, are we going to become a multi-planet species or not?
Right.
Even if we were sure Earth would be fine forever,
Right.
do you want to be here forever? I think we want to be a spacefaring civilization.
Right.
It's not like, let's escape to Mars. Do we have a spirit of adventure? Do we want to go out there and see the rest of the universe? Do we want to find out what's out there and maybe meet some alien civilizations? Do we want science fiction to not be fiction forever? And if so, we need to be a multi-planet species. That's the next step, and then we can go from there to being a multi-stellar species and get to other star systems. I disagree with the notion of rationalizing becoming a multi-planet species with advancements on Earth. It is good in and of itself. It is important that we do this, because eventually there's something will do us in.
Right.
It might be in 100 years, it might be in 1,000,000 years, but something will do us in. What it comes down to is, do we want civilization to sit around on Earth until eventually it is extinguished and all life is extinguished? Right. Or do we want to get out there and understand the nature of reality? There are grander things that we should be considering than the pettiness of everyday life.
Right, right.
Coming up, Elon Musk explains how the future of innovation could find itself all wrapped up in a lot of red tape.
We do need to be cautious about overregulating and actually ultimately limiting the advancement of civilization.
So far, we've been walking and talking with Elon Musk, discussing why humankind needs to head into the heavens.
Even if we were sure Earth would be fine forever, do you want to be here forever?
We go no holds barred with Elon Musk. Watch as he shares his uncensored views on the patent process.
Patents are for the weak.
There you go.
We needed a place that was out of the way, because these are giant rockets and they sometimes explode. So it needed to be a remote location. And it also needed to be on the ocean or on the sea, southward and facing east. So when you launch eastward, you take advantage of Earth's rotation to get to orbit. And you want to launch over the water in case something goes wrong and you don't land rocket debris on people.
Right.
Now, while Elon and the SpaceX crew have all been extremely busy building rockets and streamlining their process to make it more cost-effective, they have also had to overcome a ton of hurdles to build up this amazing facility in record time.
Tell me about regulations and red tape and all that kind of nonsense. How big a part of the problem is all that?
It's something that we should be worried about, is that the rules and regulations get more and more every year.
Right.
In the past, war has wiped away bad rules and regulations.
Right.
But also we prefer not to have war as the means of getting rid of rules and regulations. Right. In the absence of that, what happens is there are more laws and more regulations every single year, and eventually we won't be able to do anything.
Right, right.
So we do need to be cautious about over-regulating and having too many rules and regulations, basically stopping innovation and actually ultimately limiting the advancement of civilization.
And these are some of the rockets here?
Yeah.
And these are all manufactured on site here?
No, these are made in California.
Oh, these are made in California, okay. But SpaceX?
SpaceX.
Yeah, I mean, you make them.
Yeah, we manufacture the engine.
Okay.
It's the highest chamber pressure engine ever done operationally. By any standard, the most advanced engine ever made.
And how quickly can you turn out one of these?
We make them one a day.
Wow, one a day, that's pretty amazing. Is there one thing you're most proudest of, one particular achievement or one piece of manufacturing or design?
I mean, the most counterintuitive thing is making the rocket out of steel, probably.
Yeah.
We use 300 series stainless steel.
Is that something you patent?
No, we don't really patent things.
Oh, really? No.
I don't care about patents.
Oh, okay.
At Tesla, we open source all our patents. Anyone can use them.
That's what I mean. So you...
Patents are for the weak.
Yeah, you share the... There you go.
And, you know, the problem is, like, patents are generally used as a blocking technique.
Right.
They're like using, like, landmines in warfare.
Right.
So they don't actually help advance things. They just stop others from following you. And most patents are BS.
Yeah. Any lessons from Tesla that you adopted to SpaceX?
Well, the automotive industry is very good at manufacturing, and the rocket industry is good at advanced materials and making things light. So that's where the cross-pollination is most useful, is taking manufacturing techniques from automotive, applying them to rockets, taking advanced materials and design from rockets and applying them to cars.
Right. Well, Elon, I know you're very busy. I know the phone's ringing and people are trying to...
Yeah.
Thank you, my friend.
All right, thank you.
Thank you for being such an inspiration and inspiring so many young people to get into engineering and science.
Unfortunately, I have to rush to a meeting.
Go, I'll let you go,
all right.
go.
Thank you, bye. Oh, yeah. All right, thanks.
I got you.
I'll take care of this rocket stuff from here on in.
Coming up.
Mm-hmm.